to climb up to a new altitude. The V bars, like I said, are sometimes called command bars, and we'll show those later on when we get a chance. The indications that are on this artificial horizon, also known as attitude indicator, also known as flight director, also known as ADI, attitude deviation indicator. But artificial horizon or attitude indicator are the most common terms for this instrument. It's a gyroscopic instrument. It uses a vacuum pump typically driven by the engine to spin the gyroscopes that are in it, or one gyroscope that is in it. We'll talk about the guts of it later. That gyroscope spins and maintains a constant reference for the horizon. Once the gyroscope is up to speed, the horizon will match the 90-degree bank angle bars. And right now the horizon is a little lower than those bars. The pitch attitude of the aircraft is slightly above, the nose of the aircraft is slightly above the horizon, approximately 3 degrees nose up attitude. And the bank indicator or bank index levers are matched, meaning that there is no bank being indicated. If there were bank indicated, then the bottom indicator would go over here to whatever number of degrees of bank, right or left bank. 10, 20, 30 is a 60-degree bank and a 90-degree bank. 90-degree bank would look like this. A 10-degree bank might look like that. 30-degree bank, 60 and 90. The pitch attitudes or the pitch indices are showing a probably 5-degree pitch up attitude. The aircraft is climbing at a very small, very slow rate of climb, although depending on the airspeed of the aircraft, it might be moving, and the altimeter might show a faster climb than you would expect for that pitch attitude angle. This is a higher pitch attitude, maybe as high as 20 degrees like this. Some gyroscopic instruments, and this is one of the 3 gyroscopic instruments that we'll be talking about, can be damaged by pitching up too much or doing loops or other aerobatic maneuvers, meaning that they will be caused to tumble. The gyroscope is supposed to be a spinning disc and should not be pushed beyond its limits. Otherwise, you might do damage to the bearings. It might take forever for them to re-erect or upright themselves after a abrupt maneuver. Other gyroscopes can be tumbled. Gyroscopes that are in aerobatic airplanes. Some gyroscopes can be caged. Some of them have a second knob, or a knob called a caging knob, to hold that gyroscope at its neutral position and won't allow it to slam against the internal mechanism of this gauge as the aircraft tumbles, or the aircraft rolls or climbs or does any other aerobatic maneuver. So we have a pitch down indicator when the nose is below the horizon, pointed down at the ground. Pitch up indications, bank indications, and this particular gauge has a decision height warning light. The use of decision height is typically used when you are flying in instrument weather or flying instruments. The aerospace could be perfectly clear, but you're still flying on instruments, or you are still using instrument indications to make sure your course is accurate. Decision height is a term and a position that the aircraft approaches during a approach to landing. It is an altitude typically above ground, and if the aircraft is flying in clouds where there is no visibility, let's say he cannot see the runway, cannot see the airport, cannot see the ground, and he's coming down to decision height, it is typically a radar altimeter indication rather than a pressure indication. Altimeters, as a rule, are a pressure instrument, meaning that they read air pressure. A radar altimeter reads actual measurement or reads an actual distance from the aircraft to the ground. When he's coming down on the instrument approach, he might be blind. And he's coming down and he has not broken out of the clouds. Let's say this is a cloud base or ceiling, I always call it a ceiling. And it's under him, he's above the ceiling of the clear air below this base. If he has not broken out and can see the ground by the time he reaches decision height, that light will light up to warn him, in addition to his altimeter, that he must start a missed approach, meaning that don't go down further, else you'll crash into something. You might crash into something. And his missed approach must be started at the decision height if he's shooting a precision approach. And then he'll start climbing back into the clouds if he hasn't come out of the clouds, and do a established missed approach procedure. He might come around and try it again, try the landing approach again, but at decision height, if he cannot see the runway environment, he has to execute a missed approach and might have to go to a second airport, an alternate airport, when the decision height light comes on. So, attitude indicator, also called artificial horizon, sometimes called a flight director when there are command bars that come down to give a command to the aircraft, illustrated here, to climb and bank, or climb or descend. The aircraft follows and puts the aircraft shape into that V-shaped command bar. And this also has bank indications, pitch up, pitch down indications, roll indications, decision height. It's a gyroscopic, pneumatically operated instrument, one of 3 gyroscopes that we'll talk about. So far, we've talked about the OAT gauge, also a volt gauge, in Celsius and Fahrenheit, and right now it's reading 14.1 volts. We've talked about the airspeed indicator and the white arc, flap operating range, green arc, normal operating range, bottom of white, stall speed 30, flaps and gear down, bottom of green, stall speed clean, flaps and gear retracted. Yellow range, also called smooth air operating range, and velocity never exceed. 4 different types of airspeeds: indicated airspeed, what is actually indicated; calibrated airspeed, what is indicated but adjusted for position error of the pitot tube sensor and the long holes going to the gauge, which expands a balloon of bellows inside the gauge. That ram air going into the pitot tube, P-I-T-O-T, expands the air to make this gauge move. So we have indicated airspeed, calibrated airspeed, true airspeed, which is the actual true aircraft speed going through the air mass, and we have ground speed, 4 different types of airspeeds. And the instrument that we just discussed is the attitude indicator, artificial horizon. Sometimes it's called a flight director if it has command bars and has pitch up and down, degrees of pitch, up and down, nose pitch. And when we talk about pitch, we are talking about the attitude of the aircraft. This attitude is a climb, pitch up, nose up attitude. And this is a nose down attitude. Nose is pitched down. Roll attitude, roll and nose climbing attitude. gyroscopic instrument, pneumatically operated with a vacuum pump. Sometimes we'll have a standby electrically operated vacuum pump if the engine vacuum pump fails. You can spin that gyroscope with an electrically operated secondary alternate vacuum pump, motor-driven vacuum pump, electric motor-driven vacuum pump. And get into the habit of talking about, when you say motor, that's typically talking about an electric motor. We call the piston engine in this aircraft, we don't call it a motor normally. We normally call the engine-driven vacuum pump the engine-driven vacuum pump. We don't call it the motor-driven. When you say motor-driven vacuum pump, we're talking about the electric motor alternate or standby vacuum pump. Some aircraft spin the gyroscope that is in this instrument in the artificial horizon using a venturi. We might get into the situation where we're talking about a venturi. That's a very old method of driving the gyroscopes. And it's a convergent, divergent duct or tube usually mounted on the side of the fuselage to cause a suction, drawing the air from this instrument, from a filter first. Air goes into that filter and then through the gyroscope of this instrument and then out of that tail end of the duct on the side of the fuselage. That duct generates a low pressure suction to spin the gyroscope in this gauge. The next gauge we're going to talk about is the altimeter. The altimeter in this particular aircraft, and right now most all of the gauges will be inoperable. They are not operating because the aircraft is not moving or climbing. Components of this aircraft, or this altimeter, these two, or this particular one, it's called a flag, and quite a few of the gauges do have flags. They're warning flags that become visible, that they come out and show that the gauge is not operating. This flag shows that there is no pressure being sensed by this gauge, that there is nothing going on with this gauge. Other components of this gauge, let's talk about the needles. There are three needles here, or I'm gonna call them needles. This particular needle is usually the hundredths needle, and then a thousands needle, and then a 10,000th needle. This gauge right now is reading 5,800 feet above sea level, or 5,800, I'm sorry, that's not good. 5,580 feet MSL, 5,580 MSL, 5,580 feet MSL above mean sea level. That indication is actually the indication that is currently on this gauge while this aircraft is sitting on the ground in Denver. Denver is 5,280 feet above sea level as its normal altitude that is given, but because there are hills and valleys around the Denver metropolitan area, this particular location is almost 300 feet above 5,280 feet MSL. Using the term MSL, you'll see that term quite often. It is the indicated altitude above mean sea level. This knob adjusts what the indication is in the altimeter setting in the Colesman window in the altimeter. This altimeter, again, is reading 5,580 80 feet above sea level. The in-op flag is visible. Colesman window with the altimeter settings, which are typically given in inches of mercury, is here, adjusted by the knob. When that altimeter setting is put in, when you get the altimeter setting from Flight Service Station or from the Air Traffic Control Tower or from the air traffic controllers or from ATIS, Air Terminal Information Service, Aircraft Terminal Information Service, which is a broadcast. When they broadcast the altimeter setting, you turn the knob here, which adjusts the Colesman window indication. And right now, the altimeter setting is reading 30.12 inches of mercury. That gives an indicated altitude at this particular air station, which is Centennial Airport in the Denver area, of 5,580 feet. The thousands hand here, although we are still reading with this 10,000s hand, and that means 5 sets of 10 here. It has exceeded the 5, the 10,000 hand. And the hundreds hand here is indicating 5, or indicating 80 feet above the 5,500 feet. Right now, this longer hand is indicating a little bit above the 5 or halfway point between 0 and when it gets to this, it'll be at the 10,000 position. The indicator here and this indicator, both are adjustable electronically by the autopilot system. You can pre-program a altitude that you want to level off at, or don't exceed, or climb or descend to with those particular indicators, those particular bugs. They're called bugs on different indicators. Sometimes on the heading indicator, they're called heading bugs. If you want to maintain a certain heading, you adjust the heading bugs, or the altimeter in this case, the altitude bugs, to where you want them, so that the autopilot can climb the aircraft or descend it to and hold that particular altitude you have programmed into the instrument by the autopilot. Well, it is a pressure gauge. Okay, we talked about the OAT gauge using an outside air temperature probe. That's an electrical gauge typically. Sometimes that doesn't need electricity on some OAT gauges. It's like your thermometer that you set outside of your house. Doesn't need electricity to indicate the thermometer, the temperature outside. Then we talked about the airspeed indicator, then the attitude indicator. Airspeed indicator uses pneumatic air to blow into the balloon inside of that gauge. They call that balloon an aneroid bellows. It's a disc-shaped metal balloon that's flexible, like aluminum foil is flexible, and that in the airspeed indicator moves the needle. Then we talked about the attitude indicator, or also called the artificial horizon. That is a gyroscopic instrument. This one we call the altimeter. It is a pressure instrument. It uses only a static source of air pressure, meaning that its purpose really is to sense the air pressure at that particular altitude. And that air pressure varies. Even if this aircraft stayed sitting on the ground, did not fly, day to day, this needle might increase or decrease based on the air mass pressure moving through that area. If the pilot wanted to get an accurate or more accurate indication of his altitude above mean sea level, then he would get the local altimeter setting that he's either going to fly over or that he is in flying over now, he would get that local altimeter setting from ATIS, Automatic Terminal Information Service broadcast, from his radio, or he would get it from Flight Service Station, or he might request it from Air Traffic Control, ATC, or he might get it from AWOS, AWOS, Automatic Weather Observation Service, or he might get it from any other source that is available to him. The local altimeter setting will give him a more accurate altitude above mean sea level, typically. If he wanted to know his pressure altitude, he could turn that to 29.92, which is a standard MSL pressure, and it is a sea level pressure on a standard day. 29.92 inches of mercury will give him an indicated pressure altitude that he could apply to his airspeed indicator if he wanted to calculate his true airspeed by putting his pressure altitude gained when 29.92 is here, and match that pressure altitude that's indicated on the altimeter to the OAT altitude above the pressure altitude window on the altimeter. On the airspeed indicator, to indicate airspeed. Again, we're reading 5,580 feet MSL on this gauge. The next gauge we're going to talk about is typically the ADF indicator, automatic direction finding gauge, automatic direction finding indicator. Sometimes they call it the HEAD, automatic direction finder head, or ADF head. This one has a movable outside card. They call this azimuth card, a card here. Azimuth is just a series of indicated degrees, usually 360 degrees. Azimuth does indicate 360 degrees. That word AZIMUTH is indicated here with a rotating card. The knob here, labeled heading HDG, will spin that card so that you can put a heading where you want it on this gauge. But typically the purpose of this gauge is to point at the station, ground-based station that you have tuned in to the radio portion of this radio system, this ADF system. Sometimes this gauge can also function using a VOR terms. I will talk about VORs and automatic direction finding more as we go along. Again, repetition is the key to remembering these things. This particular gauge, or the needle on this gauge, is typically used to point at a ground-based station, so that if you're flying in the clouds, let's say, or if you're flying through visible, good visibility and VFR conditions, and you want to head over to that particular radio station, it might be located at an airport, and it'll guide you to that airport. Or it might just be one of the navigational aids, nav aids, or ground-based radios that you have chosen to guide you along your intended flight path or your route from Denver to wherever you're going to. If you're heading to Bahamas, your direction of flight from Denver, let's say, to a general area in Florida might be from Denver to that location. You might be flying a heading, meaning that your compass would make you head a bearing or head in a direction of approximately 115, 120 degrees on the azimuth. Normally, and we'll talk about this in a little bit, but let's say that this compass card, or this azimuth, rotating azimuth card, was actually set so that this aircraft is actually sitting on the ground, let's say, and was actually pointed, the nose of the aircraft, and this is an aircraft symbol here. That's the tail of the aircraft, and the wings are hidden by the indicator, by the arrow here. And that's the nose. Basically, it's saying that the nose of the aircraft is pointed a little bit to the right of west if this rotated card was matched to your compass, magnetic compass on the aircraft. If this aircraft in Denver was pointed at approximately 278 degrees, that's really what this is telling you. This would be north, that would be west. Behind west would be east, the tail of the aircraft would be east. And opposite of north is south. But let's say that this was not a adjustable rotating card. Let's say that the aircraft was actually sitting on the ground and was actually pointed west. It would see the mountains of Denver ahead of the aircraft. Back away from the mountains to the east would be the east coast of the United States. If the pilot of this aircraft wanted to determine his heading toward the Bahamas or toward Florida, then he would say that he would approximately fly toward the east. That means he'd take off and have to turn around and head east. But if he wanted to fly a little bit, if my fingers are pointing to the east here, and Florida is down that way, he'd want to fly a little bit to the right of east, which would be approximately in that direction to get to Florida. Approximately 130 degrees on this gauge. Again, this is a navigational instrument. You do use it in conjunction with the compass. You also use it in conjunction with a VOR if you want the instrument to point to a ground-based station called a very high frequency omnidirectional radio range receiver, or an ADF indicator or an ADF station on the ground. They actually call that an NDB on the ground. This needle will point to that station. If he tuned into a station that caused his needle to point in the direction he wanted to fly, then he'd just keep that needle on his heading that he wanted to fly. Again, it's an adjustable card radio, or head. It has a needle that points to the station, typically, and it has an indicator or an aircraft indicated right here. It, in this case, has a label on under the gauge saying that the NAV2 radio, RADIO, in the aircraft is what controls this particular gauge. It can point to a VOR. It can point to an NDB, non-directional beacon on the ground. Again, VOR is very high frequency omnidirectional radio range receiver on the ground. Has a heading knob to rotate the movable card. And if this aircraft was actually sitting and this card was actually matched to the magnetic compass, which is on top of the instrument panel, and that compass on the panel was actually indicating 280 or 278 degrees, then he would see the mountains in front of him sitting on the ground, and to take off and want to fly 130 degrees to get to Florida. And other indications on this gauge, and let's talk about zero. North being zero is typically 360 degrees. That means 0 and 360 are the same direction, same heading, same indication. 10 degrees, 20 degrees, 30, 40, 50, 60, 90 degrees is east. South is 180 degrees, 180. So if you're flying north and you need to make a 180, then you would turn around and head south. If you were flying north and you needed to make a 360 for some reason, you'd end up 360 degrees again and you'd be headed north again. 207 degrees is west, 270, 300, and that's what this indication is. You'd add a 0 for everything beyond 90. 120 degrees, 150 degrees, 180 degrees, 210, 210, 240 degrees. And there is also indicators here to help you divide those up quicker and easier. From west to this indication here, or indicator, is a 90 degrees turn. This would be a 45, which is half of 90. So every 45 degrees we have our indicator here to help you calculate how much you have to turn on this NDB pointer. It points at an NDB on the ground non-directional beacon radio station. It also can point to an AM radio station because they're in the same frequency band as the NDB. It also points to a VOR transmitter on the ground if you have VOR selected in the autopilot control head or control radio. All right, next components on the screen here. Here, this particular aircraft has electric flaps. It has a speed brake and it has a electric trim. These are reset, or this is a reset for the electric flaps and trim. We haven't talked about flaps or trim in depth here, but the electric flaps come down together on this airplane. Most airplanes probably do have electric flaps. Some have a manual Johnny bar as a long handle that they lift up off the floor to lower and raise the flaps up. But because they are electric and the trim is electric, sometimes, like a resettable circuit breaker, you can overload those electrical systems and they might need to be reset. But that's what this button is. If you operate or attempt to operate the trim on the control yoke, control steering wheel, and we'll talk about trim in a little while, but if you try to drive the trim, let's call it pitch trim, and that's what's typically on the control yoke. Pitch trim, if you pushed the trim switches, usually they move in a pair on this particular airplane. Some of them are single switches, some of them don't have any electrical trim. But if you push the switches forward on the control yoke, then the nose of the aircraft will begin to dive a little bit. And if you let go of the control yoke, and then if you wanted to hold that same descent attitude, and you let go of the control